Are you feeling warm, Yoshi?
Yeah, a little bit warm. But still comfortable.
I
Why?
um, I am too, and apparently our brains are also very hot.
But like boiling hot, right?
Well, not
Or
not
not boiling hot, but feverishly hot.
yeah, more or less.
That's
So the
that's
human brain run hot, sometimes more than 40 degrees Celsius. Um, it makes a little bit. I guess it makes sort of sense to me if you think about it, because the brain uses a lot of energy.
so it just gets warm.
Yeah, so it's like burning an engine or like having an engine running.
Or
The
like
engine
if
it will be
I
warmer than the rest of your car.
Yeah, that's true. And if I go running and use my actual muscles, my whole body will get warm. I never
Hmm.
measured it actually, but I should try because I heat up very fast when I start moving. That makes sense,
I mean, you are very hot, of course.
of course.
But yeah, the temperature of our brains varies by I think up to 3 degrees throughout the day.
Oh no.
These temperatures vary throughout the day, peaking in the afternoon, dropping at night. On average, the brains of healthy females were slightly warmer than those of males. Um, Hence why women are hotter. Um
Smarter in this case, but also hotter, of course.
yeah, apparently they looked at people with traumatic brain injury, so injured brains, and the brains of those who also had this up and down, this variation, had a higher survival rate than the brains of people who did not. I don't know if that's any correlation there or coincidence. Well, probably not, but it's all if your patient is going to die because they're almost dead, there's probably very little activity in the brain, so maybe the temperature fluctuations aren't so high as when you have an almost healthy patient. I don't know what the cause could be of that, but yeah, human brains run hot. It's a bit weird because we always thought the human body was always, about 37 degrees
Yeah.
Celsius. Is that like 100 Fahrenheit?
I have no clue about Fahrenheit. I only know miles vaguely. Sorry, no
Oh, no,
Fahrenheit.
sorry. 100 Fahrenheit is 37.8
Oh,
Celsius.
okay. So that's a fever already for your body.
Is it?
37.8. Yeah. Well, if you are paranoid about COVID, that's definitely a fever. I think you shouldn't call the. I think, but 38, you should call the doctor, maybe. But
Okay. I will take your word
or
for it.
like, if you feel very sick and are 38, you can call the doctor and ask them. Yes, but yeah, 37.8 is pretty warm. So this was my amazement with the study of the brain, that the brain can run at 40 degrees. I thought it was like what I learned about fever is that your body like heats itself up to kind of slow down some virus or bacteria that is in there causing some sickness, right? So it should be bad for your cells and for other cells to run at 40 degrees. That's the point of the fever.
Yeah, that makes sense.
Yeah, this is what I learned at least. So it's funny that the brain runs at 40 degrees like a normal, because proteins they react differently at some point. If you like, it's like boiling an egg, right? If you make it too hot, the proteins will change their configuration and their function. So it's I don't know, to me it's very interesting that the brain as a normal in normal function runs that hot. But maybe also, wait, it would also be because it fluctuates over the day. That's also very interesting because the activity of the cells, of course, changes when the temperature changes. Everything goes faster or slower. So then, like depending on what the brain is doing or wants to do, it can change the temperature and the function will change. That's pretty
True.
cool. Pretty cool.
I must say I have noticed when when you're operating, it's easier to maintain anesthesia when you put the heating pad a little bit lower.
Oh, that could be.
I've had some
That's
trouble when you're operating on mice. You always place them on a heating pad so they don't get too cold. They don't maintain their body temperature very well under anesthesia, depending on the form of anesthesia used. And I've always noticed if you put that a little bit colder, like 1 or 2 degrees colder, they tend to maintain anesthesia better. And then if you want to wake them up, they wake up quicker as well.
And
They just
the theory behind it would be that you slow down the brain and
yeah.
activity.
Hmm.
But yeah, no, this makes sense because I was now worried actually when I read this. I was worried about patch clamp experiments that I did because in slice we always maintain the slice at a constant temperature.
Yeah, that's true. We usually work at 35 degrees. Some labs use room temperature. 35 degrees. I've always thought it was slightly too cold.
Yeah,
But the warmer you set it, the more quickly the tissue degrades.
yeah.
So if you're working with brain tissue, you don't want that to be too warm.
No, you don't want to. But so I think many labs work 35 degrees, so you can compare
Hmm.
results very easily. But
Well,
then apparently this is still pretty low. Like it was already a bit low, and now it's even lower than maybe the brain actually operates. It's it's pretty
yeah,
funny.
I mean, this is in humans, though.
Yeah, yeah. This is
Um,
also what I was wondering. It's in humans, but so we have to measure in mice what the temperature is.
hmm.